signal flow graph, or we call it as SFG. There are certain definitions, etc., which I'll explain as we do a problem. I think that is better for us. Okay, but there is something known as Mason's gain formula, very important, many times from the examination point of view also, because when people find that there are no more questions to be put, they just put it as explain what is Mason's gain formula. Mason's gain formula. It's very easy. When you hear this for the first time, you may feel it's a little difficult, but no, it's very easy. Mason's gain formula is used to find out the overall gain. Overall gain. Overall gain is one and the same as the overall transfer function. He has given us overall gain is P is equal to 1 by delta sigma K Pk delta K. Just write this down along with me. The overall, as per Mason's gain formula, the overall gain is P is 1 by delta sigma K Pk delta K, where I am writing, so you also should write, okay? Pk is the path gain of the kth forward path. I'll explain all these terms. Pk is the path gain of the kth forward path. Delta is 1 minus sum of all different loop gains, plus sum of gain products of all possible combinations of two non-touching loops minus sum of gain products of all possible combinations of three non-touching loops, etc. Sigma K is the value of delta for that part of the graph of the SFG, of the signal flow graph, not touching the kth forward path. We were discussing about block diagram reduction till now. Now we are going on to the next topic, which is signal flow graph. Why did you go to signal flow graph? Because we found that although block diagram reduction method is useful to us, it is a little tedious process, because every time you want to find a certain block, reduces a block diagram and bring up to the level of the transfer function, you found that a number of times you have to go on redrawing the block diagram, and it is a tedious process. So we are adopting something known as a signal flow graph, where I'll explain all the details later on, but I am coming up with a very important formula, which is known as Mason's gain formula. Now, Mason's gain formula directly gives you the overall gain. This is known as overall gain, which is the same as our overall transfer function. This is very important formula. That C by R, that C by R is equal to P. That is equal to 1 by delta sigma K Pk delta K, which means Pk means kth forward path. I will discuss about forward paths. And then we have something known as delta and delta K. What is delta? 1 minus sum of all different loop gains. I'll explain what is loop, plus sum of gain products of all possible combinations of two non-touching loops, minus sum of gain products of all possible combinations of three non-touching groups, etc. And this delta is also called as a determinant of SFG. Determinant. Delta is also known as the determinant of the SFG. And then you have one more thing, which is delta K. You have delta as well as delta K. Delta K also you have to find out as you found out delta. But the only difference is you have to find out that value of delta where the kth forward path is not touching, which means you call delta K as the cofactor of the forward path of the forward path. Okay. Now, why I wrote all these, I took the pains to write all these is because you many times they ask you what is Mason's gain formula and you have to state this formula as I have written here. You should know by heart. Okay. And I am sure that you will know by heart when we do problems. First question. For the signal flow graph shown, for the signal flow graph shown, find x5 by x1, x1, x2, x3, x4, x5. Okay. A, B, C, D. E, F, G. This is the SFG given, signal flow graph given. And what was the Mason's gain formula given? P is equal to 1 by delta sigma K P K delta K. This I am sure by the end of this class you will remember. P is equal to 1 by delta sigma K Pk delta K was the Mason's gain formula. P is our x5 by x1. Why do I say that P is our x5 by x1? Because the input is x1. This is x5. All of you should know that x1, x2, x3, x4, x5 are called the nodes of the SFG. Nodes. So what are nodes? Nodes, a node is a point representing a variable or a signal. A node is a point or a point which represent a variable or a signal, which means നമ്മുടെ ഇപ്പോൾ block diagram we had this CS, RS, CS, etc. These will be represented by a node R, C, and whatever transfer function G, I'll represent it like this. Instead, in this problem, I have represented by A, B, C, D, G, F, E. These are all equivalent to G, and X1, X2, X3, X4, X5 are equivalent to R and C. Okay, X1, X2, X3 up to X5 are nodes. What are nodes? A node is a point where representing a signal. Now branch means x1 to xd is a branch. Another thing is branch. Branch is x1 to x2, x2 to x3, x3 to x4, x4 to x5. These are all branches. It is a directed line segment joining two nodes. Directed line segment joining two nodes. I hope you understood. These are all nodes X1, X2, X3, X4, X5 are nodes. This is a branch. Which is the input node? Next thing is the input node. What is meant by input node? Input node here is, as you very well know, is X1. Or how will you define that? It is a node having only outgoing branch. You have only an outgoing branch. Similarly, you can have an output node. Output node is a node which has only an incoming. But you can have an X6 here where I can say it is an output node. Okay. There can be mixed nodes. See, X5, X4, X3 are mixed nodes because there are branches coming in as well as branches going out. You have branch coming in and going out. So those are mixed branch. But next thing that you have to know is a path. What do you mean by a path? A path is a traversal. 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 Traversal means it's just going. A path is a traversal of connected branches. A path is a traversal of connected branches in the direction of the branch arrows, in the direction of the branch arrows, such that no node is crossed more than once. Which means path from X1 to X2 to X3. AB can be one path, or ABC can be another path, or ABCD can be another path, or CD can be one path. Those are all path gains. Now, one thing that you have to remember is these are all paths, but when does it become a forward path? It becomes a forward path when the path extends right from the input node to the output node, or write that forward path. What do you mean by forward path? These are all paths, but forward path means it is a path from the input node up to the output node. The loop. A loop is a closed path. A loop is a closed path. Can anyone identify closed paths here? Closed path. CF. Closed path. That is, you start from X3, go to X4, and come back to X3, which means CF, the path gain or the loop gain will be CF. CF, this is a loop. Similarly, BE is another loop. Similarly, DG is another loop. So you should always understand that these arrow marks are very important in SFG. Very, very important. If the arrow mark was in the opposite direction, you cannot take this as a loop. Understood? Then, third, in the last definition, non-touching loops. Non-touching loops. Non-touching loops. Loops are non-touching. Loops are non-touching if they do not possess any common node. Loops are non-touching if they do not have any common node. Step 1, number of forward paths, or you can you can just write this as forward paths. Forward paths. How many forward paths are here? Forward path means the path which goes right from the input node out up to the output node. How many forward paths can you identify? In the definition of the path, I said no node should be crossed more than once. I can take only one forward path here. This forward path alone I can take. തിരിച്ച് ഈ പറയുന്ന G and F and E all are for feedback paths. If I consider any path along with E, F, and G, I will be crossing any of the nodes more than once, which means I have only one forward path, P1, having path gain A, B, C, D, which means I got this in the Mason's gain formula, which I have written. I got this value, PK. Step 2. Now my investigation. ഇതിൽ എന്താ അറിയാം, നിങ്ങൾ ഒന്നും ആലോചിക്കണ്ട. ഇവിടെ നമ്മൾ മറ്റേ ഇൻ ആർ ബാലരമ എക്സെട്ര വി ഹാഡ് എന്താണ് ഒരു റാബിറ്റിന്റെ കുഞ്ഞിനെയും വെച്ചിട്ട് ഇങ്ങനെ വെച്ചിട്ട്, റാബിറ്റ് ആണേ, ഇവിടെ ഒരു ക്യാരറ്റ് വെച്ചെന്ന് വെച്ചു, ഒരു ക്യാരറ്റ്. അത് ടീച്ചറിന് വരയ്ക്കാനൊന്നും അത്ര അറിയില്ല കേട്ടോ. അത് ക്യാരറ്റും വെച്ചിട്ട് നമ്മൾ പറയില്ലേ ഈ ദിസ് ഇസ് റാബിറ്റ്, എൻ്റെ അടിയിൽ എഴുതിയാലേ റാബിറ്റ് എന്ന് മനസ്സിലാവും. ഈ റാബിറ്റ് കുഞ്ഞ്, സ്മോൾ ബേബി, ഈ റാബിറ്റ് കുഞ്ഞിന് എങ്ങനെ ഈ ക്യാരറ്റ് എടുക്കാൻ പറ്റും എന്ന് പറയുമ്പോൾ നമ്മൾ നേരുള്ള വഴി മാത്രമേ നോക്കുള്ളൂ അല്ലെ. ദാറ്റ് ഇസ് കോൾഡ് ആസ് ദി ഫോർവേഡ് പാത്ത്. ഓക്കെ, സോ ഹിയർ യു ഹാവ് ടേക്കൻ ABC. Step 2. In step 2, you are thinking about loops. Identify loops here. As I told you, loop 1 will be with L1. How many loops are there? How many loops are there? 3 loops. L1 I'll take as BE. This loop. This yes. Loop BE. L2 I'll take as CF. A loop is a closed path. Step 3. I am checking for non-touching loops. Non-touching loops. Okay, I am having 2 non-touching. E loop non-touching, as I told earlier also, because it doesn't have a common loop, which means the loop gain will be L1 L3, that is equal to BE DG. I hope you understood up to this. നമുക്ക് നെക്സ്റ്റ് സ്റ്റെപ്പിൽ എല്ലാം കിട്ടാൻ പോവാണ്. സ്റ്റെപ്പ് 4. In step 4 I am coming to the final answer. Step 4, overall gain P as per Mason's gain formula is 1 by delta sigma K PK delta K, where PK I got delta is equal to 1 minus sum of all loop gains, which means individual loop gains, BE plus CF plus DG. BE plus CF plus DG plus sum of loop gains of 2 non-touching loops. Which are the 2 non-touching loops that you got? BE DG, which means I'll write this as BE DG. This is my delta. Delta K. So I got PK, I got delta. Now I am focusing on delta K. What is delta K? I said delta K is the value of delta itself, but for that part of the graph which is not connected to, which is not connected to the kth forward path. Delta K in my case will be delta 1. In my case, delta K will be delta 1 because I have only one forward path P1. So first forward path touch cheyyatha loops undo ennu nokkana. You have to check whether there are any loops which are not connected to the first forward path. Is there any loop which is not connected to the forward path P1? Illa. 1 minus 0. Had there been any loops which are not connected to or which is not touching forward path 1, you would have written that here. And if there are loops, then you will check for 2 non-touching loops, 3 non-touching loops, etc. So here delta 1 is 1. I can combine all these things and write the final answer which is asked in the question as x5 by x1 is equal to P is equal to 1 by delta. What was delta? 1 minus BE plus CF plus DG plus BE DG PK delta K. What was PK? Instead I can write A, B, C, D and PK into delta K. Delta K was 1. This is your final answer. This is your answer. Delta K is, you write the value of delta for that part of the graph which is not touching the first forward path. Delta 1 means you are going to write the value of delta for that part which is not touching first forward path. We have only in our case, in this particular problem, you have only one forward path, isn't it? Now, so which means I have to write delta 1 as 1 minus all the loops that are not touching the first forward path plus all the two sets of non-touching loops which are not touching the first forward path, and so on. Fortunately or unfortunately, we don't have any loop that is not touching the first forward path. This is your first forward path, one and only forward path, and every loop is touching it. Delta 1 will be 1 minus 0. No loops are there.